So this is a medium problem from the characters arrays section. It's add 5555. Basically it allows us to input a string and then add 5555 to it. Usually you'll get an overflow problem with your integer if you have a very long integer when trying to add in C++. Because of the limited size of the bytes. So to combat this, there is a way of solving it using strings, and basically by taking one individual character in the string, converting it to integer, and then repeating that process so that we can add 5555 to our string input. So there's a couple of examples. Let's see how it works in actuality. So I'm going to call this string just the input, and we'll do this in a for loop. Again, using the casting to ensure the input size is an integer. And before we continue, we'll need something that will display whether we have a remainder or not, and it allows us to include a remainder when we're calculating each element in our string. So the first thing we need to do is take the final digit in whatever our input is. Let's say our input is 100,000. Then the final digit in that is going to be, well, the input size minus 1 minus I. But at the moment that's just a character. Assuming we've input like the character 1 or the character 2, it's not an integer value. To convert a character to integer easily, just do that. Subtract the character 0, and it would take something like the character, the string character number 9, and converts it to the integer 9. Now, we're only adding 5555 to this, so that means we're only looking at the last 4 digits. So if I is less than 4, i.e. it's going to be one of these, we're going to add 5 to the digit, like so. So that's pretty clear so far. However, after we've done that, we need to see if that digit has gone over 10 or not. If the digit is greater than or equal to 10, then we're going to subtract 10 from it, and our remainder value now equals 1. If the digit is not equal to 10, well, we'll just make sure that our remainder is set to 0. However, there's one thing missing in this, because when we're doing the first character or the last character in our input, it's quite easy to forget that we're going to need to add a remainder for all future characters. It may be that the first character will not have a remainder, but subsequent ones might, if our digit has gone over 10 for that specific character. So to make sure that we're including our remainder correctly, basically if we have a remainder, if it's 1, if it's not 0, then digit, we add 1 to our digit. Okay, and at the end of all of these calculations, we're basically taking this value, now you shouldn't copy and paste, but basically we've done our conversion. We take the input int size, input size -1 minus I equals digit plus 0, and that should work like a treat. There's one thing that we also need to do for reasons I'll show you in just a moment. If after exiting this loop we still have a remainder, we're going to need to output 1 before we output our input. So let's have a look at some of the test cases and compare them to what this program has given us. So first, 100,000, that gives us the correct answer. Secondly is well, that's about 10,001,234. There we are, that's also the correct answer. We also, this one's often the one that is the real test. Let's use the 10,99999. There we are. Our remainder 1 has been added in the correct place, and the rest of the calculation's good too. And finally, let's see if the kind of final boss of this challenge is the extremely long input of 9s. There you go. So that works pretty well. The one thing I'll show you, if you omit that, if the remainder line, well, you don't get the same kind of result. Not at all. If the remainder is still there, we need to make sure that we put it before the string input output.